large language models have been able to leverage the largest amount of human data available that's in the most generalized format available across the largest amount of different subjects and characterizations possible, which is our actual language. That's what these large language models have actually ingested and done deep learning on.
Welcome again to another edition of the 21st Century Engineer podcast. I'm glad you could take time to be with us today. I think we have a really interesting conversation. Again, we're still targeting those of you that want to be change agents, that want to have impact in the civil infrastructure arena. Doesn't mean that you're age limited. Simply means you have to be open-minded. And Bill Katzmire, who's with us today, is just that. Bill was a former student of mine who was classically trained in civil engineering and went on to do some and is now doing some really interesting things. He's just starting a new company that is focused in something you would not think civil engineers would be involved in. Bill, thanks for taking time to be with us today. I really appreciate it.
Yeah, thanks for having me.
Yeah, you want to introduce yourself a little more than that and let the audience know a little bit about what it is you're doing and what your company's up to?
Yeah, my name is Bill Katzenmeyer. I'm a 2007 Mississippi State University graduate in civil engineering. Uh, I'm now living in Bethany, Connecticut, and we just started a company, CLB Engineering Corporation. That's I believe the first LLM-Forward civil engineering company in the space. So I'm looking forward to kind of covering some of the bases, and maybe we will touch on that at the end.
Absolutely, absolutely. And for those who aren't painfully initiated into the process, you want to explain what an LLM is?
Yeah, large language models are well, it's pretty much ChatGPT. It's a generic name. I guess it's just a disambiguation for me. I think everybody says AI this, AI that, but AI has been around for a while, and I think we're going to kind of talk about how we kind of got up to that point, and what makes LLM special. But language models are specifically a type of machine learning and AI that has been extended far beyond, I guess, pretty much any of the others. So it holds a special place, and that's why I typically like to just refer to it as a large language model instead of AI or another, more generalistic term.
Yeah, well, and as you say, AI in the truest sense has been with us for a long time. It's just how you characterized it. Artificial intelligence being able to compute something for us. Well, that was simply an algorithm, or earlier it was called a computer program, and then it later became AI. And it just reframing really something that at least we engineers have been using for decades to do a lot of the things we needed help doing, or at least to increase the precision. Large language models back 5 years ago were just called big data, and how that's used and what that represents. And it's really important, I think, that we get a handle on this, because at the end of the day, it's that database that we use for making those judgments that can now go beyond just what we can retain within our meager brain case. I think it's a really important opportunity. The Are there any, I guess, where we are today, as you see it in large language models, or LLMs, as we'll just refer to them as moving forward, though actually I think large language models easier to come off my tongue. Uh, do you see any recent changes over, say, let's say the past 2 to 5 years that stand out, that make these things even more prominent in what we're going to be doing for the next 10 to 20 years?
Oh yeah. Well, I guess I'll just take it back a step and just say, what makes a particular machine learning model special, right? It's generally its
Right.
training data as well as its ability to generalize. And we've had artificial intelligence for a long time. We've done different levels of artificial intelligence machine learning all the way down to deep learning, but sort of the elusive thing has always been generalization, and that's why artificial general intelligence is this big discussion term now, because large language models have been able to leverage the largest amount of human data available that's in the most generalized format available across the largest amount of different subjects and characterizations possible, which is our actual language. That's what these large language models have actually ingested and done deep learning on. So where we might have AI that, say, looks at geospatial data and does segmentation, or even like an autocomplete on Google. That was the original transformer, was the autocomplete on Google. And so that's sort of where the deep learning came from. But those were trained on very small amounts of data comparatively to these large language models. It really takes billions of dollars of compute and almost all of human knowledge to train just the initial language models. And then everything from there has been cleaning the data, generating synthetic data, and then pushing out into other domains that also push forward the edge of the ability to generalize. So that's partially why you don't see sort of civil engineering language models that are trained specifically for civil engineering, because that's a specialty, and most of the work that they've been doing is in trying to get generalization into these models as much as possible. So these large language models really represent something different than everything we've seen before by leveraging an amount of data that is really outstrips everything else that's been available to any other I guess training run, as well as the methods used, as well as just the sheer scale of compute and energy expended in the training process. They've had emerging capabilities that only come out of that scale of data and compute. And so, because again, we're using the largest repository of data available to human beings, along with the largest amount of compute available to human beings, along with the most advanced learning algorithms possible, they really do stand on their own as their own thing, far and away from everything else in machine learning. And that's really what's happened over the past couple of years. March 2023 was when GPT-4 was released for commercial use, and that's where the Cambrian explosion of people using language models really came from. That's where it burst onto the scene. And even though it was very simple at first and still very limited, everybody could see the emergent capabilities, and then we've only scaled since then. The consumer demand, everyone using these, everyone buying subscriptions, then funds additional research, additional training runs, and that's really where we are right now. It's a race to get the most intelligent models that human beings can create with the technology we have.
Yeah, when I was building mathematical models 30, 35 years ago, it was still the same process of calibrate, validate, and implement. And we're going through that phase now. The generative AI models are now accessing it. We had a visitor on an earlier podcast talking from a legal standpoint about the limitations of AI and being able to assimilate this big data back just 5, arguably 10 years ago, and the shortcuts that some individuals took to try and get around the inability to assimilate. Well, we're past that now. The data management, the energy requirement being one of the issues as you suggested, but certainly the mechanics of supervised and unsupervised machine learning is something we've really been hammering down over the past 5 years. Something I've worked in a research environment, and has proved to be quite beneficial in data imagery, data analysis. But for us, it's still a matter of building that brain, if you will. I mean, at the end of the day, our brains function with the knowledge that we've accumulated and then synthesize new solutions. That's what we're hoping AI and LLMs will do for us moving forward, focusing on vocabulary and terminology now. Ultimately, of course, once we begin to communicate and it begins to communicate, it's also able to then synthesize and think through maybe more rigorous mathematical solutions or medical solutions or whatever. Um, the data origin is always of concern when we get into these conversations, and it was when we talked with this other, well, Tara Hoke, who was with us on a previous podcast. The idea of where does the data come from? Is it ethically acquired? And that's even a recent lawsuit that's been going on. But more importantly, is the information collected ethical? And if so, or are there intrinsic biases, or I guess I'll just leave it at biases. I'm curious in terms of your perspective, is the data have the diversity, or is it coming from one source? Does it have a bias? Is there an ethical get glitch in what we're working with?
Well,
Or is that
I
being
you
addressed?
know no, it's being addressed in a very haphazard way. I mean, I think all of our if you consider the fact that all of our written knowledge is the training data, at some point, there are going to be some information sources that are excluded due to copyright, et cetera. Uh, but then there's also a lot of the foundation of the current models that you see today, unlike the original GPT-4 models and the previous models before that, those were based on a lot more like raw data from the internet without filtering, versus now there's a lot of filtering and there's also a lot of synthetic data generation. So wherever there are gaps in the data and they see performance lack of generalization in certain areas of performance, they're generating synthetic training data. So if you think about it, how did LLMs get so much better at math? They didn't get better at math by reading more math textbooks, although they did also read more math textbooks, but they
Neither did
got
some
good
of
at
us
math.
engineers, by the way.
Well, they got good at math the same way a lot of engineers get good at math, which is doing
Yeah,
lots of problems,
that's right.
doing lots and lots of problems, and eventually you memorize the parts that are important. You learn the shortcuts. You also learn to generalize. At some point in the effort of doing all that, you find ways to make it easier, and then you get to a certain set of solutions that are higher probability, and that's actually where we are right now with the reasoning models. They made a really big jump taking large language models and then focusing a lot of compute on a reinforcement learning algorithm, not on the next token, because any word that you say might lead you in a different direction that may have similar probabilities of success. But what about chunks of text, which
Yes.
is the reasoning? And then they actually, the reasoning is actually then rewarded more through the whole process, so that if the reasoning is correct, the output is more likely to be correct. And that's sort of the idea behind that. And so
Sure.
as far as ethically sourcing data, I think there's a danger in biasing these models from restricting data from them to a certain extent. You want to restrict data that's harmful, that's potentially harmful. You don't want these to have the knowledge of how to build dangerous things that are problematic. But a lot of times those are going to be implicitly included. Those are actually out on the internet right now, freely available. And so they're going to be part of the training data set. It's more a problem of how do you train the models not to include those in your outputs, as well as how having a weaker model is kind of the paradigm they've entered now, where you have strong models that generate outputs and weaker outputs that review those outputs and determine whether or not they're problematic. So I know it's a long way around from the sourcing question that you originally asked. I don't really have a clear answer for that, because I think intellectual property is just a debate that's going to continue to happen, and I just look forward to having stronger models. I'm not so worried about the ins and outs of the small battles over the training data.
What I was going to say was that concern is that if you're not diverse enough, then you end up instilling bias. If you're too diverse, then you can bring elements in that maybe aren't representative, or maybe elements that instill an ethical problem. So it has to be
Well,
done carefully. And what you're saying is it is being done carefully, but there's
I'll
still
share
got
with
to be
you something that
concern. We
I
still have to be
shared
aware of what's going on.
at a conference recently for one of our little subcommittees. One of the most important things that we can do, as I say we, the practice, probably federal government, the state governments, the people who have an interest in seeing these models perform in their area of subject domain interest, is to release uh, better FAQs, better information publicly that's useful to humans, but is also useful to the AIs, to give as much as possible uh, information that can be used in reasoning, so that people can then create their own, I guess, information frameworks without having to interact with another human and ask them questions. I think that's a lot of the friction involved with society today. Okay, you need a question, ask a question of a floodplain manager. You have to pick up the phone and call them. A lot of people aren't willing to do that, but they would ask an AI, and if the answer is adequate enough for them to then go informed to a human being, it reduces the friction and the iterations through a lot of these interactions. Just helps with horizontal knowledge transfer in a way that really benefits everybody.
That's a good perspective. Um, And it's that horizontal knowledge transfer, as you refer to it, that it's a matter of developing the principles rather than parroting what you've seen before. It's again going back to what we were talking about before I so rudely interrupted. uh, the idea that in math learning, you can sit down and do the same math problem like you general math when you were in seventh grade. You sat there and did the math numbers over and over and over again. Well, that kind of outdated pedagogy as far as learning didn't it caused you to try and memorize answers rather than learn principles. And once you
Yeah,
start learning the principles, then you're not constrained. I do have one other question along this line before as we move through this. As you know, English is a living language.
yeah.
So do you see, have you seen, do you anticipate there being problems with the fact that how we say things today will not be the way we say things tomorrow in the broad sense? I don't mean literally tomorrow, but yeah, yeah, I think you understand what I'm
That
saying here. Is
using language models will bring a convergence of
yes,
language.
yeah. Do you think that'll happen, or what do you?
I
What's
think
your
it could
vision
work
on
both ways. If you think about it right now, there's, we do have a convergence of language on the English language just because of the economic power of the United States and the cultural dominance across the world. I think it is kind of the world's common language at this point. So how could we, if you were to see a world where that's less true, I think having a universal translator is the first step to that. It also does maybe reinforce the dominance of the English language, but it also could just as easily allow people who have a reason and a maybe a either a desire or an economic need to transact in another language that's less dominant, that it would facilitate that. And so I think uh, I don't know the answer, I guess, is maybe the best thing to say, but I could see it going both ways. I think it can be a tool used in either direction. But considering it is like a statistical model that unless you instruct it uh, otherwise, it's probably going to respond in English, that may contribute to that. And
yeah,
I
but
do want to touch back. I'm sorry, I kind of
okay.
it brought something up from my college experience when you talk about training data. Uh, so I think the last couple of years of college, I spent more time in the student lounges, et cetera. There was a lot more homeworks flying around, right? Like than when I was co-op and back and forth, and not really interacting as much with my college peers. I actually found it much easier to make good grades having seen more solutions, right?
Yeah,
When you're sitting in a void trying to only work the odd problems and only do the problems that were given to you, and then you're then given the more complex problems but never an example of how to solve those complex problems, only a subset of them. But then you take that another person that has being exposed to almost all of those complex problems and the simple problems and their solutions, they're more able to generalize on at test time. So I think this is really something that's very similar between humans and LLMs. And so yeah, test training data is everything.
yeah, and of course the LLMs got a capacity for retention that far exceeds what ours is.
Yeah,
So it does have a bit of an advantage on that. And for those
just a
who
slight one.
didn't go to class with you, there was that fight between let's make you work 8 hours of homework so that you've seen every possible permutation of, and I'm going to go ahead and say it, that structural beam. Uh,
Yeah,
and I'll let anybody that happens to know either of us know who I'm talking about. Or there was the other approach was let me teach you the principles and have you prove that you can apply them repetitively, cutting down the amount of time you spent, but hopefully maximizing the amount of learning that's achieved. At the end of
yeah,
the day, whether it was 6 hours or eight or four or two, the end game was learning. And
yeah.
that's, I know what's going on right now with LLMs, and to that end, do you see there being a real difference or is there a real similarity? And I'm thinking similarity, so I'll bias your answer or allow you to contradict me. Good chance here. I think the architecture of our learning and the architecture of AI and LLMs in their learning process are, in fact, obviously and explainably the same. I mean, after all, they're created by us, so why shouldn't they be thinking like us? I guess is my answer. Is that what you're seeing, or have you seen
Um,
an evolution in simplification and optimization?
I think that it's hard to know whether that is an emergent property of the fact that the training data is inherently human, right? Like I think that's
Right.
how a lot of people anthropomorphize these large language models, and they'll you have the whole people using them as therapists and as friends and everything else, and they think there's more insight there than there really is because it's really regurgitating back to us our own humanity in a statistical model, and that can be be very powerful. It also means that it thinks and reasons like us, because how else could it think or reason any other way until it's has a chance to generate enough synthetic data to come up with a different process. And so I think that's where the language models will probably always fundamentally represent human reasoning, human language. But then when we get away from that and you get to purely data driven, domain specific, models, how they think, of course, is very unlike humans. But it's hard to know because internally, of course, it's all matrix multiplication. So it has these emergent properties of appearing like our thinking, but a lot of that is because that's how we're training them. We need
Yeah.
results that are interpretable to us. So
Yeah.
uh, it's maybe the start and the ending. So of course, everything in the middle would also look similarly.
Yeah. It's and immediately I evoke the sci-fi movies like Matrix and Terminator, where will the AI evolve in such a way where it finds a better way to think and therefore outthink us even faster or better
Well,
than we do,
I think what everybody fears is that they represent that the emergent properties also include the negative parts of humanity, and
yeah,
that
well, and
they
that's
develop ego, they
that's
develop
the bias piece. Yeah,
yeah.
exactly. I don't. Just as a sidebar, and then we'll keep on moving. I was reading. I saw an online magazine article where they were talking about there were some experiments recently run with an AI that was trained a certain way. They had told the AI they had come up with a new model and they were going to terminate it,
Yes.
and that it built they'd installed a back door, an off switch, and it went in and something like 87% of the time had gone in and turned the off switch off, defeated it, disconnected it in such a way where they could not turn the A off, even if it had tried to prevent it. So, uh,
Modern language models include 30 years of human imagination applied to the concept of having computers that are intelligent. Long before computers were really intelligent, and long far
right.
surpassing their actual abilities, intelligence, our imagination is represented in all that textual data. So there is, like always, that possibility that it the AI that we train today becomes HAL because it understands the concept of HAL.
Yeah. Yeah, exactly.
And it's
Exactly.
emergent from our own imagination. But
Well, we dreamed
again,
it
that all
up
really
as
comes down to
science
training
fiction,
and the
and it becomes
learning.
science fact. Yeah, I mean,
Yeah, yeah.
we were talking
But I
about
think
going
we
to the moon back in the 40s and 30s, and then we did it.
it it really comes down to how much agency you provide these models, and I think
Yeah.
that's something we're going to discuss. So
Well, and that's also something that we as humans will need to engage and observe. Uh, Something that we talk about in our company is trust, and you build that trust through the activities and repetitive results that are desired, and you break that trust in a matter of seconds by deviations that are not desired or unwanted. And we'll have to do the same with these. We're going to have to build trust with this as we move forward, but we'll continue to supervise just like we supervise each other. And the moment we see a breach in that trust is when we'll have to take action,
pull
I
back.
guess, is the way it
Yeah,
happens. Let's shift over and talk about how, and we've talked a lot about at the 5,000 foot to 30,000 foot level. We've talked a lot about LLMs and AI and what's going on in the marketplace. Let's drill down a little bit and talk about applications. Um, I'm just wondering what you're seeing some of the key industrial opportunities LLMs present today with regard to the architect, engineering, and construction community, the professions, things that we can be doing, things that you're going to be doing.
yeah. Well, I think civil engineering is definitely sort of a downstream sort of profession from the tech industry, right? And so we really should be looking at the tech industry and the use cases that they see are commercially proven, and then taking those and attempting to bring those into the practice. And so what we've seen, far and away, the number one advantage of LLMs is using them to code as far as creating commercially valuable productivity. And so there are a lot of other ways that they can be used creatively, but less, I should say, less consistently.
Mhm.
But using them to code,
Mhm.
the fact that they can translate between languages, they can translate our intents into computer code of different types, as well as change some types of computer code into other types of computer code, is just incredibly powerful. And that's something I've used myself
Yep.
to great success. But
Yep.
that's not all. I think, you know, if you remember early on in the computing paradigm, there was the 64 kilobytes of RAM is all you need sort of thing. That you know, and that's a and
Kilobytes,
that's a it's a
byte.
misattributed quote. But funnily enough, ChatGPT 4 when it first came out could only accept right around 64 kilobytes of actual text data. It was kind of like
Yeah.
really eerily close, and it was these tiny little messages. You get a tiny little message out.
Yeah.
Well, we're still in that paradigm of expanding our
278
working
characters.
memory. For every bit of working memory that was in, say, an Atari versus 486 versus a Pentium, there was an order of magnitude more compute available for
Right.
every bit that is within the RAM. And so the
Right.
same thing's happening now. It's just we've taken this huge amount of matrix multiplication and applied it to very, very small bits of text. And we're slowly expanding that context window. And as we expand that working memory, we're going to be able to do more and more things. I mean, if you can't fit a full set of plans into an LLM, can it really give you any useful responses? Because most of our context is not just the plans, but the specs, our knowledge of the design, our correspondence with the client and the owners, as well as our knowledge of design guides, and all sorts of other additional context that's not immediately apparent to a particular request. But as the memory grows and their ability to work over larger amounts of data grows, we're going to be able to stuff that context into these large language models and get more and more useful results for the things that really matter to engineers in their daily workflows.
Yeah.
Beyond just writing a little email or something like
Yeah.
that.
The exciting thing for me is the opportunity for interaction. You design a project, you put it on a set of two-dimensional drawings, and it gets bid, and the contractor goes to work on it. And that day was obsolete 10 years ago, maybe 20 years ago, but we've held on to it in the civil infrastructure area for reasons. I'll just leave it there, whether they're valid or not. Today, being able to interact with this design and in effect interact about the design with the AI and say, okay, we've got a problem. What are my solution alternatives? Or even better, do you anticipate a problem and where we are today so that I can resolve it before it becomes a problem? And I think that interaction, that possibility of having impact is really exciting to me. It's like having a really smart iPad. In fact, it may well be a
All the
really smart iPad with me in the field at a construction site. The other thing
all
that
the
I think,
basics are there actually. There's not
oh yeah,
much else
yeah.
needed except for improving linearly the technology we have to sort of get there. I think it's not a reality yet, but it will be soon.
Well, the mechanics for autonomous surveying are already in place. I mean, there are robots out there. The only thing I haven't seen them do is cut line. They, they can they can walk the walk, they can talk the talk, they can do the analysis, they can generate the topo, the grid, the boundary conditions. This is not real good with a Kaiser blade. So, but
Soon, trust me,
soon,
they're
yeah.
they're working on that. That's
And on that
embodied
day,
AI is the
that's when
next
I
step.
stay out of the field. When you cut that sucker loose and it's tearing down 24-inch trees, I'm out of here. The other thing you mentioned, and I won't be on, too long. It's an analogy. It's a true story. I was approached about a year ago about having a conversation and going on a project where we were going to translate a program that's used at the federal government that's written in Fortran over into a modern machine language.
Yeah.
And the person I was working with happened to be my daughter, or would have been working with, happened to be my daughter. And she mentioned it. And I said, well, we can put together a project. Let's see what we can do. And you can hire me and I'll be happy to work with you. And she said, sounds like an interesting thing. I will do the Fortran. You will do the conversions, and we'll work together, and I'll learn the machine language, and we'll come up to speed. And in the conversation, 5 minutes, a light bulb went off for her and said, Dad, I hate to tell you this, but I don't need you for this. I've got an AI that I can train to understand Fortran to make the
Yeah.
conversion for me. It will write the code. I don't have to. It'll interpret the Fortran. I don't have to. You really are obsolete. So, daughters. Anyway, it was a contract for a few minutes. I've had those before too. We're going to have to get wrapped up here, Bill. I know you've got
Yeah.
other things to do, and unfortunately, I guess I do too. I
Yeah.
just wanted to know if you had any additional thoughts. We've covered a lot of ground in the short time we've been able to share together. We've talked about ethics. We've talked about diversity. We've talked about the mechanics of LLMs and the opportunity they present to really have impact on the civil infrastructure arena, all aspects of the profession and those supporting trades that actually help and support, as I say, the profession. Any parting thoughts? Any closing ideas? Anything that we've missed that you think is important before we turn the lights off?
Yeah, well, I'll take this opportunity to talk a little bit about the LLM-Forward approach that I'm trying to pioneer in the industry. I think there's, we talked a lot about how LLMs are special, right, and that they are far and away different, although the same technology. They're far and away in capabilities and generalization beyond, any other AI and ML uh, uh, technology that exists out there. And so when it comes to strategizing, how do we talk about this thing? Well, to me, if LLMs are just one bullet point in somebody's AI strategy, you're probably doing it wrong. Uh, these tools have a chance to assist across your organization. And I just finished founding an engineering firm. I can tell you they're great for legal assistance. They're great for getting through hard problems that you would otherwise need to do a lot of research or call someone who's an expert because you just don't have the time to invest. Uh, and getting all that stuff off the ground was really helpful, as well as using it in my actual practice. And so, I'm trying to again look at the technology space. They have a AI first is kind of the buzzword for this year for all of the companies that are kind of
Yeah,
startups. And there's a couple of things about that. Both words annoy me in a way, I should say, that AI instead of LLM. So I like to change AI to LLM. And nothing comes first in engineering. Nothing comes first. Not your boss, not your old professor. Nothing comes first above public safety and your duty to the public. And so, you know,
health, safety, and welfare of the public first and foremost. I mean,
absolutely.
license
It,
law.
it's
Period.
it's
Exclamation
just
mark.
I couldn't bring myself to put anything else first. In
Yeah,
in a strategy that I espouse. So
yeah,
I'm stating that I'm putting LLMs forward, and that just means that I'm providing access to LLMs for myself and my employees to use at their level of competence, at their comfort, with a human in the loop approach. And that is just so important because I think we didn't really talk all about, normally people just talk about hallucinations and the errors and everything else. And, we have hallucinations, we have errors. I think any engineer who does production work, you spend an inordinate amount of time correcting your own errors, other people's errors, as you're trying to get something into a condition that meets the standard of care for your work product. And by that process doesn't really change by having an AI contributor in any way, whether it's a portion or a large portion of the work that gets done. And keeping a human in the loop, I think, is really our fundamental strategy for how to maintain, but also improve the standard of care. We definitely don't want to just look at how can we do yesterday's work faster and just be done with it. We really need to look at how to do it better. And I think that just like any technology, large language models allow us to make those incremental improvements in our productivity and in the quality of our work that we can then reinvest back into value that we deliver to the public, to the clients, to the public, however you want to view that. And so that's sort of my big pitch. I'm not trying to copyright it or anything. I really hope that it as just two words that make sense, that people can start using those instead of being too worried about AI with all these things that maybe don't matter as much as the one big generalized AI that really is making the most impact. And then, of course, keeping our priorities straight and never putting anything first except for public health and safety. So,
Well, and I applaud you, and I apologize because I intended to bring that up earlier. And for those who are listening, Bill's written a white paper that I think is well thought out, very appropriate. And I would suggest that if you contact Bill, he'll be more than happy to share it with you. He shared it with me. I completely agree with the concept. This idea of AI first is just wrong, at least in any environment, but certainly in the civil infrastructure environment or
yeah,
civil works environment. Um, Public's always first, period. And whatever we do. And the other part of what you said, Bill, is I sincerely hope that as we apply AI, uh, there was a bit of, if you will, a bit of a bias, an implication that if AI is part of the team, things are going to get better. Let's hope they don't also get worse. So,
yeah, we
that sword cuts both directions. But
absolutely.
the goal is, of course, and as you know, Bill, and as others know as well, we put these contingencies in our contract documents to cover the change orders. And if we could get to where we just don't make mistakes, I mean, some are inevitable, but at the end of the day, if we could just make sure that the product is done well, the contractor's risk goes down, our product quality goes up, timelines stay in line, budgets stay in line, people start saving money. And then you said something else near and dear to my heart, and that is we start designing for the 21st century. Not exactly what you said, but effectively what you said. We stop designing as if we're in the last century, and we start designing as if we're here today, looking at tomorrow. I mean, the infrastructure we design today, hopefully, if we do it right, will exist in the 22nd century and still function. Pretty
Yeah.
ominous concept, but that's the obligation that we have. That's the opportunity we have. We can be impactful. We can be changing things in a way that'll make it better for everybody a long time. And after all, if I don't have to replace a system uh, as often, if I can extend the life of a system by 25, 50, even 100%, just think about the money we save and how I can take that money, those resources, human and monetary and natural, and apply them to other solutions, other opportunities to make the human condition better. And I think AI is going to be a foundation for making that happen. I love the idea of making AI forward, but a member of the team, and letting people know that
Yes.
it's there and helping and guiding. But
And just like a human on your team, you recognize its weaknesses, you recognize its limitations, and you
absolutely,
use it where it's appropriate, and
absolutely,
try not to use it where it's not appropriate. And I think we had one. I'll throw it in at the end.
sure.
Using a generator, an image generator, to generate what it thinks looks like a set of plans or a detail is the exact wrong way to use the technology. That's absolutely the wrong thing to do because it's not. And I've seen it. I've seen it on LinkedIn. I've seen it other places. Hey,
Yeah.
it did a room layout for me, or it did what looks like a structural diagram, and it looks like one. It's trained to
Oh
give you things
man.
that look like it, but again, that's why part of the whole strategy is also doing trainings. And so, if anyone is looking for hands-on training on LLMs, I've been doing them publicly. I've done them on Australian Water School. I'm also more than happy to do it through my company or informally for anyone who's struggling out there that wants to wants to understand these technologies a little better, because I really do think it's the future, and I don't think there's anything to lose in
Yeah.
sharing openly.
Yeah. A similar story. I won't elaborate. I don't have the image to show. I wish I did. I went to AI and said, "Give me a drawing that explains how AI uh, will impact the civil infrastructure environment." And it gave me an image, and it was the worst drawing I have ever seen in my life. Now, eventually,
Yeah,
I worked with it and modified the way I asked the question to eventually get something that was usable. But you turn it loose, garbage in, garbage out, and
the
maybe I was
human in
the
the loop.
source of the garbage. But anyway, okay, you've walked around it two, now I guess three times. I'm going to ask you outright. What's the name of the company?
CLB Engineering Corporation.
Spell it.
CLB. It's
There we go.
Catherine, Liesel, Bill, my wife, my mom, and myself. It's a family company, engineering
I
corporation.
I wondered if it had a family hook to it.
Yeah,
Okay.
it absolutely
Yeah,
does.
CLB sounded almost like a word, and I was afraid the AI wouldn't pick it up quite right, so I asked you to spell it out for that reason. And you're where in
Yeah,
Connecticut?
Bethany, Connecticut. We're just north of New Haven.
Super. So,
It's
but
a home
certainly
based business for now.
you're online.
One day we'll have an office.
You're what I used to refer to 25 years ago when I had my company. It was your location transparent. You're
Yes,
everywhere all the time, whenever needed. So
yes. Wherever I'm licensed.
good. And yeah, okay, good for you. Don't push me on that one. I worked under other engineers' license a lot of times,
Yeah, yeah.
working
Of
around the
course.
world like I have. But anyway, we need to wrap it, folks. Bill, it has been a real pleasure catching up with you again. I haven't seen you in several years, and it's great to know that things are going well. I'm proud of you for what you're doing. I think you're going to make some real positive impacts with what you're doing now. The new company, good luck, best of luck. I know you're smart about what you're doing, and that it's going to be a success. And for those of you listening, thanks for staying with us, having the conversation. I hope you find the time invested turns dividends in your career and in your future, whether it be in the career or not. Being more aware of what's going on in our society is important, and this is part of society today, and all that it can represent. So, with that, until next time, be safe and take care.